My dear students, being students of geography, we are often to map our surroundings according to their position and scale. But before going to discussion about map and scale, let us have some fundamental ideas about dimensions. Around us, some points objects are there which has neither length nor area nor volume. These are just points. Suppose in this map, the all the junction of streams are just a point. Here, two stream joins together and makes a point. In this map also, the road crossings are considered as point. Some linear objects are there which has neither area nor volume like this. It has length only. In this map, the same drainage basin, the streamlines has length only. And in this map, the road network are of linear objects which we have to map, like this road. Some aerial objects around us are also there which we have to map, like this, which has length as well as width. Suppose the same drainage basin, it occupies some area and we have to map it. In this case, different states and the country, it occupies some area and we have to map them. Some volumetric objects are also around us which has uh, width, length as well as thickness, like this. The planet Earth, its satellites and other planets are volumetric objects. These buildings, block of buildings, are volumetric objects because this has length, width as well as thickness. Now, to conclude, we have point objects which has no dimension at all. Let's consider this point on a line. If you want to locate this point, you have to move either this direction or this direction on the same line. That's why it has only one dimension. And think about this point. To locate this point, you have to move towards x axis, this direction, and towards y axis, up towards this direction. And think about this point on a cube. The location of this point could be located by the x-axis and y-axis and z-axis. So this to locate this point, we have to consider three dimension. Now let us see how a point can be changed into one dimensional, two dimensional, and three dimensional objects. Suppose if this point move in a particular direction, it creates one dimensional objects, that is a line. And if this line move in a particular direction, it makes two dimensional objects an area. And if these two dimensional objects, that is area, move in particular direction, it makes a three dimensional object. In this slide, you see some objects which have no dimension. Those are road crossing, river confluences, and it has no dimension, neither x nor y nor z. Rivers, road, it has only length and have only one dimension, that is x dimension. A plots of land, a country, a river basin, this has two dimension because this they cover some area and it has dimension x and y. Some objects like the earth, a mountain, a building, that has three dimension, that is x, y and z. As point has no dimension, so it has no unit at all to measure. As length has one dimension, so its unit of measurement are units of length, suppose centimeter. For two-dimensional objects, the unit is centimeter square. Here I have add the dimension of the object as power to the initial one-dimensional unit, that is centimeter. And here the three-dimensional object has three dimensions, so I have add these three as power function to the centimeter. Now, if on a map the length of a road or side of a plot is doubled, then what happens about the area of that plot or the map? Simply, the length 2x is used here, and again the same way I have add 2, that is dimension of aerial uh, parameter as power function, that is dimension is used as power function. 2x remain constant everywhere, just power function is used, dimension is used as power function for area and for volume. Now, if area is double, here x square has been changed into 2x square, then what happens? It is the best policy to go to one-dimensional unit. The length would be changed as this root 2x square. 2x square is constant, root 2x square, because it has two dimension, it has one dimension, so 2x square root is the length. And For case of three-dimensional objects, the volume will be root 2x square, the unit of dimension of first one-dimensional length, that is powered with the dimension of volumetric objects. It has three dimension, so power 3 is the dimension of this three-dimensional objects. Now, if the volume of a globe is twice, then what happens to a line on that globe or an area on that globe? So, volume has been changed from here x cube to 2x cube. Then length of an offset, length of a line on that cube change this way: cube root of 2x cube, and area will be cube root of 2x cube to the power square to the power 2. Now always ask yourself, your teacher, what, where, when, how, and why I do, and don't stop until you are satisfied.